Okay, hello everyone. Welcome to another time series session. This will be the third one, and again, I'm planning to continue. So I just shared with you the link for the second module and the third module. So what are we going to do today? Today, we are going to continue with what we left last time. So we haven't finished the second module, so we are going to continue with the second module. In the second module, we are going to we just learned about, actually last week we learned about how to create lag variables. So we are going to use these lag variables this time to make predictions, first of all. And we learned about Windows function, actually just one window function. So we're going to learn about expand function this time, or method this time. So we learned about rolling the other time. So we're going to add expand as the second one for the window functions. So, and then we are going to talk a little bit about moving averages, and then again use moving averages in making predictions. So that will conclude the second module. For the third module, I'm going to start with talking about what is white noise or Gaussian noise, and then do some exercises on white noise. And then we're going to spend some time on autocorrelation, which I think is very important to understand before we move forward with any kind of time series models. So what is autocorrelation? I'll try my best to explain it using code from scratch. So we're going to see how we can check autocorrelation for a series, time series. And also we are going to see that we can easily find autocorrelation or plot autocorrelation using some methods from pandas. Okay, so that will be all for today. So hopefully we can finish this all, actually. So it's going to take a while for us to finish all this. Again, I know that we are waiting to learn more about time series models, getting into ARIMA. So what is P, what is Q, all that. So we are going to learn about that. But before getting into any kind of, that's very easy. So we can easily get the data and then apply a model. But before getting into that, I want to feel more comfortable with dealing with time series data sets. Okay. All right. For those who just, just 1 second. Yeah, I'm going to share the links one more time for those who just joined us. So I shared the links. Chetan, I am going to I promised to give some book recommendations. I will do that. So for those who just joined, I'm sending the link for module 3, and this is module 3. Okay, and the module 2 is right here. Let me just copy it, and this is module 2. So we are going to start from module 2 again. If you could please open session 2. Session 2 file. And this is where we left last time. So what we were doing was we were reading daily minimum temperatures data set, right? And then we were assigning the date. So let's read this first. Okay. And then see how it looks like. Just to remember what we are dealing with. We are dealing with daily minimum temperatures data set. It's a CSV file. We imported it. We read it, actually. And then what we did is we assigned the date column as the index. And then we also turned the strings, which were looking like date, but they were not in date format. We turned them into date format, okay, date time format. So now our data frame has an index of date as date. Date is set as the index, and then we have the temp, which is indicating temperature for each day, the minimum temperature for each day. So that is what we did last time. And then what we did was we created a rolling window with width of 3. So what it means is, let me run this one. So first of all, we shifted the temp data. So let me show you what shifted looks like, just to remember things. Okay, so this is how shifted looks like. We shifted our original data set by 2 time periods. So what it means shifting by 2 time periods is the data for the date 0101 is actually shifted 2 down to 0103. As you see, I have not a number values for the first 2 dates, because when I shift 20.72 down and 70.92 down, because there is nothing 2 before, right, for both data points, I need to put here not a number, right? So because there isn't any number before 20.7 or before 20.7, so there are 2 numbers missing, right, before 20.7. That's why the first 2 rows are not going to be a meaningful number. Okay, so this is shifted. All right, this is shifted. So we call this shifted. Another thing that we did is we created a window where we use this shifted data frame. From this shifted data frame, we create a rolling window of width 3. So what it means is for each data point, I'm going to consider a window of size 3. So what does that mean? Let's say I'm considering the first row as my first data point. So for this first data point, I am going to consider, like, I'm going to imagine there are 2 more data points before this one, which there aren't, right? So I will consider a window of 3 data points. Let's look at this 1981-0105, 18.8. Okay, when we are at this 5th data point for the shifted data frame, when window size is 3, as it is here, right? The width is 3. Then I am considering a window of 3 data points, including my current data point. In other words, 20.7, 17.9, and 18.8. Now, if you try to see what window, as of here, as it is here, window is a rolling window of the shifted data frame. Now, if I want to print window, I'm not going to see any data points. So it only tells me that window is an object. It's a rolling window of size 3. Okay, that's it. So I need to do some operations, run some, call some method for window. For example, I can say window mean. So let's see what's going to happen. When I do this, as you see, I am calling a method mean for this window object. What it does is it takes each data point. Okay, for each data point, it considers a window size of 3 and takes the mean of the 3 data points falling into that window. Now, you are seeing there are 4, there are 1, 2, 3, 4, not a number records here. So why suddenly we had this? Again, remember, window is a rolling window on this shifted data frame, and window size, the window width is 3. So what happens is you take the first data point, which is not a number, and that we are considering 2 more data points before this first data point, which they don't exist. So I cannot take the mean of 3 not a numbers. The mean of 3 not a number is not a number. I go to the next data point. Again, I'm going to consider 3 data points, including this one. Again, not a number. Next, I'm going to consider the 3rd data point. Again, this time, again, window width is 3. I'm considering 20.7, not a number, not a number. The mean or max or mean of these 3 will be not a number. So I'm going to get my first number as the mean of the window for the 5th data point, because the 5th data point, it has 2 meaningful, 2 numbers actually before 18.8. So now in my window of size 3 or width 3, I have 3 numbers. Now I can take the mean of these 3 numbers, which is 19.13. So last time we not only did mean, but we also checked max and min. So I can do, instead of mean, I can do mean. This time I am taking the minimum of the 3 numbers falling into that window. So this is a very, very useful method that you can use for time series. Sometimes you have to, which we're gonna do some examples on that. Sometimes you have to consider a window. Let's say that window can be a 1 week. Okay, can be as the width of the window can be 1 week worth of data set. So you are going to consider that window data falling into that window, you are going to consider that say as your history, and then you're going to make your prediction for the next day or for the next 2 days or the next 3 days. Then you're going to shift your window by, say, by 1. So every time you go to the next data point, your window shifts, so that you are going to only consider the data points falling into that window as your historical data points, or as your archival data set. Okay, so you're not going to consider anything before that window or after that window for training the model. So that is one way of testing models. Another thing is, what you can do is, every time you start from left to right, so time, imagine time is stretching from left to right. So you come from left, and then each time you add 1 day. Let's say you started from 3 months before, and each day you're adding 1 day of data. So let's say at first you had only 1 week of data. The next day you're going to have 8 days of data. The next day you're going to have 9 days, and then 10 days, and then 11 days. So each day you're going to have 1 additional day worth of data. So then you're going to train your model with richer historical data to make predictions. So every time you predict the next day, let's say. So this is not exactly the window that we are talking about. So we are now expanding, which we're going to see in a minute, our data set. So window functions are very, very useful when we deal with time series data sets. All right. So far we took a window width of 3, and then we considered mean of the 3 data points falling into that window, taking the minimum or maximum. So this is what we did last time. This is exactly where we left last time. What we did is, after we took the original data set, this is 2 shifted version of our original data set. This is the minimum of the window of width 3. This is the maximum. This is the mean. Now I am concatenating these 1, 2, 3, 4, 5 columns. Okay. And then I have this new data frame where, as you see, for each date, I have 1, 2, 3, 4, 5 variables. Okay. And then this is my original temperature per day. This is 2-day shifted version. And this is the minimum, maximum, and mean of, again, for this day, 0105, as we just covered, right? 18.9 is the minimum of the 3 days, the temperature of 3 days, including that day. So 17.9 is in this case, the minimum of, 17.9, I'm considering 10 plus 2, okay? I'm considering 10 plus 2, that's why I was a little bit confused. So I'm not considering 10, because I created window on 10 plus 2 column, okay, right? So 17.9 is the minimum of these 3 data points, 20.7, 17.9, 18.8. 20.7 is the maximum of these 3 data points. 19.13 is the minimum. Okay, so mean of those 3 data points. So this is only the first 5 observations. Imagine that we did this for the entire data set. All right, so this is where we left last time. Let me see if you have any questions. Share module, the one which is share module 2. Okay, so I just shared with you module 2. Let me share it one more time for those who just arrived. Okay, let me know if you have any questions, please. Yeah, okay, I just shared it. All right, let's continue. Before I am going to make, or let's first make run a linear regression model, and then I'm going to come back and then talk about expanding method of window object. Okay, so what I'm going to do now is, remember we created let's create a new data frame. Okay, let's create a new data frame, and this is going to be a an exercise for us. Just I'm going to take let me see. Okay, so let's do it this way. Before I do any linear regression, okay, let me just follow what I planned. Let me introduce you expanding method, and then we do some linear regression. Okay, all right, it's gonna be better, I think. So I'm going to again import my data set. Please just bear with me, because we already did this before, but this is for the sake of making an exercise. I'm gonna read my data set. Okay, So here I'm going to just copy the name of my data set, which is here, daily minimum temperatures. I'm also sending this as a message to you so you can, oh, it is empty? You mean, I see. So, I see. So hold on. I understand the problem. So I'm going to copy this. Just 1 second. And I'm going to copy this into the student folder. And just wait for a couple of minutes. It is going to be available, George. It's going to be available. So you are asking for the file that we already did work on it, right? So I just put that file into the folder. Just give a couple of minutes for that to appear in the Google document, Google Drive. Okay. So what I was trying to say was, yeah, let us read these daily minimum temperatures. Okay. One more time. All right. And then let's do this as an exercise. So I am reading this daily minimum temperatures data set. Okay. And then what I'm going to do is, as I did before, I'm going to assign the index column, okay, as date. Okay. Index column as date. And then I'm going to parse the dates into date format. So the date is, let's do this first. Just let's remember how it looks like. Okay, as you see, I have an index column. I have the date, and then let's also see how it's. Okay, as you see, date is an object. In other words, it's a string as of now. I'm going to turn this into, I'm going to turn date into date time and also make it, instead of 0, 1, 2, 3 as index, I'm going to make date as the index. That's what I'm going to do. So instead of writing it, I'm just going to copy this. Yeah. Okay. Now let's check the date. Yeah, as you see, I turned, and then let's check the info one more time. As you see now, temp is only the variable I have. And if you check the, so date time index, right? So data frames index is a date time index. Okay. So I got my data frame. So what I'm going to do is I'm going to take the temp column. Okay. I'm going to take the temp column and then create a new data frame out of that. Okay. Just, I want to make things as explicit as possible. Okay. So what I'm going to do is I'm going to turn the temp column. I'm going to first take the temp column. Okay. df temp. Okay. I'm going to take the f temp column, and then I am only going to take its values. So let me show you how this looks like. So let's know what we are doing. All right. I don't like just following things blindly. So when I take this, okay. So as you see, I only took the temp columns. Right now it is a series. So I'm going to take the values of this. Now it turned into an array. Okay. At first, without values, it's a series. Now I took the values of that series, put it into an array. So that means this is an array. I'm turning that array back into data frame. Okay, just for the sake of example. Okay, so temps is a data frame now. All right. So what I'm going to do is, now it's a pandas data frame. Pandas data frame has this method called expanding. So I'm going to take temps and then put expanding. All right. And then let me assign this to a new variable. Let's call this temps2. Okay. Now let's see what temps2 looks like. Again, we know what temps look like. Temps. This is how it looks like. Temps. How about temps2, which is the temps dot expanding? Okay. As you see, it's not giving me any value. Actually, temps2 is an object where the called expanding method of pandas on temps data frame. So I need to do some operation using expanding, okay? I need to call some method that I did earlier, right? So for example, how about temps, and then I'm gonna say mean, okay? Temps expanding and then mean, and then let's see how temps look like. Okay, so it looks like it looks like something that we did not see before. So again, let's call the original. Let me also check the original data frame. This is the original one. So 20.7, 17.9, 18.8. So what it does is expanding. As we move down the data points, we are always going to consider everything before the current data point. Let's say we are on number 2, okay, 19.13. We are always, so in the original data set, let's say we are at number 3, 14.6. When we are here, we are going to consider everything up to this point, including 14.6. That is what expanding does, all right? So when I say expanding dot mean, what I mean is at every step, I'm taking the mean of all the data points up to that point, including that point, all right? So in other words, the first data point, 20.7, it's 20.7. The second one is 19.3. Actually, 19.3 is the mean of the first one and the second one. The third one, 18. 18 is the mean of the third one, the second one, and the first one. So with expanding, what I do is I'm actually, as I move down my data points, I am considering everything before, including the current data point, everything before that data point too, and taking the mean of that. So can I just, what is that? How can I use this expanding? We're gonna see in a minute. Okay, we're gonna see in a minute. So let's keep this in mind. This is something different than the rolling window, right? So with rolling window, we have a window, and then we move the window, right? And then we only consider the data points inside that window. Here, what we did is we expanded it. We are considering all the data points before and including that current data point. All right. So what I'm gonna do next is I'm going to, as I did before, I'm going to create a new data frame. Okay, let's call this data frame new. Okay, and that is a concatenation of, okay, I'm going to put inside this list the concatenation of, I'm going to take the minimum of everything. Let's say if I'm here 3, 6, 4, 5, when I'm here, I'm going to take minimum of everything before and including 14.0. Okay, that's what I'm going to do. So I'm going to take temp, what was the name of that? Temps2. That is the expanding version. Not temps2. I'm going to say, I'm going to take the minimum of this guy. Okay, comma. I'm going to take the mean of this guy too, temps.mean. We'll see how they look like in a minute, temps2, by the way. And plus, I'm going to take the maximum, okay, of this. And also, let's also shift the original data set by 1, okay? Let me show you how it looks like. This is my original data set. I'm going to shift this -1. So let's see how it looks like. Okay, look, 17.9. So it was 20.7, the first data point. Now I shifted -1, not +1 this time. So what I did is I created temps t plus 1, right? So I took the next data point and brought back into the first data point. So the first row is going to have my original data set as well as the value of my next data point. Okay, so let me put this here, temps.shift. These are all manipulations where you can do when you work on your time series data set. I'm gonna concatenate them along the axis 1. Okay, now I'm just curious. By the way, let me also name my columns. Data frame, I call this new. Columns are So the first one, let's call it minimum. The second one, let's call this mean. The third one, let's call this max. And the fourth one, it's t plus 1, right? So when I shift by -1, I am actually considering, if this is t is 0, I'm considering the data point for t plus 1, right? Because in the original data set, the value of t plus 1 is 17.9. So when I'm here at t, this is t plus 1, right? So that's why I'm going to call it t plus 1. Of course, this should be a string. Okay, now let's check how our data frame looks like. Data frame new dot head. Of course, head should be. Okay, perfect. So 17.9. So suddenly we see these NANs. Did I do anything wrong? What do you think? Let's see. Times 2. Oh, times 2 should be just expanding. Let me take this down because I took times 2 times expanding mean. So it is taking the minimum of the mean. Of course, the minimum of the mean is going to be wrong. So let me put this one here so that everything now will be okay. Perfect. So the first 5 data points, right? We can even put temps here too, so that we have the original data set as well. Okay, so this is for time t 20.7. This is for t plus 1 17.9. This is the minimum so far and maximum so far and the mean. So when we go to the second row, the minimum of the first 2 rows is 17.9. The maximum of the first 2 rows is 20.7. This is the mean of the first 2 rows. And this is the third row value, 18.8. So in one row, okay, as I move down the data points, right? So I have mean, max, and the mean of all the data points before. And I also have the next data point. So what I can do now is I can take the very last column and assign this t plus 1 as my target column. And I try to predict when I'm at t time t, I can try my best to predict t plus 1, right? So that is what actually we are going to do. With using time series data set, we are going to predict the future, right? So t plus 1 is 1 day after. So what I'm going to do is I'm going to use for each row, I'm going to use that row to predict the value for the next time period. So t plus 1 will be my target variable, and the other 4 columns will be my they are going to be my feature set, right? Capital X. Okay. Let me see if you have any questions. I missed module 1. Can I get it for that by any chance later? Sure, Hajime. So I'm going to give you the module 1 when I give break, okay? All right. So let's do this. What I'm going to do is I'm going to call from scikit-learn. Okay, I'm going to use a linear model. Okay, model. I'm going to import linear regression. Of course, this should be together. Okay, so that is what I'm going to do. Let me. Okay, so this is what I am going to use from scikit-learn. I'm going to use linear regression. So before doing anything, let me just get rid of any missing values in my data frame. So data in my data set, data frame new. We did this before. I am deliberately using it one more time just to remember what we did. Data frame new. So what I'm going to do is I'm going to select only the rows where I don't have any null values. Okay, so data frame new is null. So again, remember when I say this, It's going to give me all true, false values, right? Just remember, it's going to give us all true, false. If it is true, that means there is a missing value. If it is false, that means there isn't any missing value for that cell. Okay, think of this as a table. I'm looking each cell if there is a missing value or not. Missing value in this case is not a number. Okay, so apparently here there is a missing value because the last data point t, when it is 3649, I don't have t plus 1. That's why there is a missing value. Okay, so I don't want anything with missing values. What I'm gonna do is, if there is any missing value in any of the columns for any row, I don't want that. Okay, so now I shouldn't have this last data frame, this last row. It should be gone. Okay, so let's check the right. So this is 3649, but the index is 0. So it was 3650. Now we have 3649 because the last row is eliminated. Okay, I just wanted to make sure that we know what we are doing at each step. So we called scikit-learn linear regression. Let's instantiate one instance from linear regression. So linear regression from linear regression class. Okay, I am going to get one instance. Let's call this linear regression 1. Okay, so it's going to be a very simple model. Next thing is I'm going to split my data into X and Y. X will be my feature set. Y will be my target variable. X will be from data frame new. This is my data set. I'm going to drop this very last column, which is my target variable, t plus 1. Okay, and this drop is going to occur on as one column. Okay, this is X, and then Y is data frame new. I'm just going to select t plus 1. Okay, all right, I have my X and Y. So what I'm going to do is now I'm going to train a model using X and Y. So lin reg 1. Okay, let's fit X and Y. So I trained a linear regression model. And next I'm going to predict, okay, lin reg 1 dot predict. I'm going to put all my features, and so again, remember, Y is the true value, lin pred Y. So let's call this Y hat. Y hat is the predicted Y values. Okay. All right. So let's see how Y and Y hat looks like. Okay. So Y hat 10. I'm just showing you the first 10 observations, and Y 10. Okay. So this is the first 10 observations from my predictions, and these are my true values. So I'm predicting the next value as 20.2, but it's actually 17.9, right? So these are my predictions, and these are my true values. So one thing I want to try is, remember, I just included this temps as one of the data points. Let me just exclude this one and then see how. Let's do it here. In addition to t plus 1, let's also drop t as well. Okay, and then let's run our linear regression model one more time. So it does, in this case, in my opinion, it does a better job in terms of predicting if I only use mean, max, mean of my previous data points. If I just use the previous ones, like the data from T to make prediction for T plus 1, so data from T and then mean, max, all that can be correlated. Okay, so I don't want to have any problems. I think this works much better than including t. So we just tried both cases. You can try in many different ways. So this is a very simple example that we are trying to show that you can create a very simple model with using a single column of data, but we are creating new features, and these new features are minimum, maximum, mean of previous data points. And what we are trying to do is we are trying to predict the data or the temperature in this case for the next day. Okay, one thing before I move forward, the true values are often called observed values, observations or measurements. That is true. So ground truth, true values, observed values. So statisticians, econometricians, and machine learning people, they might use their own terminology, but yes, I'm using true values because mostly we use in machine learning true values or ground truth for indicating that those are the labels. I can even use labels too. Thank you, Andre, for the comment. I missed more. Yeah, Hajime, I'm going to share this. I'm just checking the questions if there are any questions from time to time. All right. One thing before I go to the next topic is what I want to do is I want to calculate the error. So yeah, we made a prediction, but how good we did with this prediction. So how are you going to know whether your prediction is good or bad? Okay. So for that, I'm going to use one of the metrics available from scikit-learn for regression models. I'm going to use mean squared error. So I'm going to talk about it in a moment. Import mean squared error. Okay. So what I'm going to do is import. Let's first import this. Okay. So what happens is mean squared error, mean squared error. Okay. After I imported this mean squared error of y and y hat, what it does is it takes the true value y, the label true value observation y, and y hat. For each observation takes the difference between true and the predicted ones, takes the difference. After taking the difference for each observation, takes the squared of that. So let me write this explicitly. So y1 minus y hat 1, okay? And then square root of this. And then takes the next data point, y2 minus y hat 2 squared, okay, plus. So you add each and every observation. You do this for each and every data point, okay? And then after you sum this up, this is the squared error. Now the mean means you divide it by number of y's, okay? In this case, we have 3, 6, 4, 9 data points, right? So we're going to divide this by 3, 4, 6, 9, or we can simply say data frame new dot shape 0, right? So this is going to give you the length of the data frame. Okay, so this is mean squared error. If you want to take the square root of mean squared error, that we call it RMSE. Okay, it's going to be more meaningful because I don't want to deal with squared errors. RMSE is going to give me a much better it's going to be a much better measure for me to understand how much I am deviating from the true values when I make a prediction. Okay, so that's what I'm going to do. For that, I'm going to import math. Okay, you don't need to import math. If you like, you can simply say, let me do this to the power of 1/2. Right? This is going to work. Or what you can do is import math and then say be more, what is that, formal, all right? You can use the square root method or from math module and then take mean squared error y hat. Okay, again, I am trying to do my best, treating myself that I don't know anything about this, so I'm learning everything from scratch. This is RMSE. Again, it's going to give the same thing. Of course, to import math and then let's see what is RMSE. Okay, 3.95. So on average, when I make a prediction, on average, my prediction is deviating from the true value by 3.495. So look at the values. These are the true values. So these are the true values, 17.980. So when I make a prediction, on average, I am deviating from the true value by 3.9. For example, for the first case, it's almost like 0.9, right? The deviation is 0.9. For the second case, it's almost like, 1.9. So, but on average, when you consider all the data points, it's 3.9. Okay. So again, the question is this good? Is 3.9 good or bad, right? So what did we do here? I want to do something more. What I want to do is, you know what, instead of going through all these predictions, right, we created a new data frame. We used the mean, max, and mean of the expanded window, right? And then we use that to make prediction for the next day. So what if you did the, what if you did the following? You took the average of all the data. That's one thing. So there are different ways you can. What you can do is, well, you can use today's data to make prediction for tomorrow. As you can simply say, tomorrow will be the same with today. It's not going to work because all your predictions will be the same then, right? So all your predictions will be the same unless you use, each time you use historical data from the previous day. So let's say today is temperature is 17, then you predict tomorrow is 17. Now you go to tomorrow. Now you know what is the temperature of tomorrow, right? You're not going to use your prediction to make another prediction. If you do that, then all your predictions will be the same. So tomorrow, you know what is the temperature in reality, right? The true value label is now, you know that. So you use that day's temperature again to make prediction for tomorrow. So this is a very simple case, which you can do. Another simple, even simpler case is take all the historical data, take the average, and then say that this is my prediction. Okay, so let's do it that way. Let's say our prediction for all the days is actually the mean of my data set. So what I'm gonna do is I'm just going to find the mean. This is mean, right? So let me show you the mean. Right. So this is the mean of my labels, true value. It's on average, the temperature is 11.17. So that is what I'm going to use as my prediction for all the data points. So I'm going to take this and then create a NumPy array of this with length of y. Okay, so now I create the array and let me create this NumPy array. So as you see, all my predictions are 11.17. Now I'm going to use this as my prediction, and I'm going to use mean. Let me copy this and put it here. Okay, so this is my true value. This is my prediction. And I need to close the parentheses. This is the parenthesis for mean square root. This is the parenthesis for the square root. 4.06. So my model, earlier model, in terms of RMSE performance, right, a measure or metric, if you consider this a metric, is doing, I would say, slightly better than the case if I had used the average of the temperature for any, for my prediction for any day. Okay. Now this is homework for you. What if you want to use yesterday's? Actually, we can easily do that, right? What do you think? Can we do that easily? So how we're going to measure? How we're going to create a prediction, an array of predictions, which is going to predict yesterday's temperature for today's prediction, today's temperature for tomorrow's prediction. We learned about this, right? You're just going to shift your true label by 1 and use it as your prediction, right? Let me leave it for you, and then I think you can handle it. There is a typo. Yeah, this is, yeah, I was just, yeah, I wasn't planning to run this. Thank you. I just wanted to show you that how you can use, how you can find the root mean squared error. Okay, let's continue. Let's continue. So this was one example. Now the next thing is, again, I would like to do one more example using how we can read data from a CSV file, how we can parse the date into date format. So I just want to do one more exercise. I got this exercise from a website. Okay, I just want to go through it step by step with you and then understand what is going on. And then we are going to go to resampling, interpolation, and moving average smoothing. I'm going to give a break in 5 minutes. Let's finish this example, and I'm going to give a break. Okay. All right. So let's import again. I know we imported pandas before, but let's do it one more time. Okay. And then I'm going to import datetime. Actually, from datetime, I'm going to import datetime. Yeah, Zuhair, you are asking for recorded version. Yes, all these sessions are recorded and then they are posted at YouTube channel. Okay, so Magnimind's YouTube channel. You can watch it later if you like. All right, so let's now here. Let me show you. I am going to work on this Apple CSV. Okay, Apple CSV. That is the data set that I'm going to work on. So first of all, this is my original data set. So I'm going to read. Okay, Apple data set. Yes. Okay, so let's see how the data looks like. Just okay. So this is the first 5 observations. We are very lucky to see that there is something unusual in the first. Is the very first record here, right? The first cell in this table. We may not be this lucky to see, I mean, wrong data. In this case, it's very easy for us to see. So you might spend some time when you first read the data set. You might spend some time to understand, to see if your data is if there is any missing or wrong data points in your data. Okay, here we are very. So I'm just going to delete this row and then continue. But let's see. We have dates. First of all, we have the indices. We have dates, and then this is the close. So this is actually the what is it? The stock for Apple, right? So this is the close price. This is the volume. This is the opening, and then on that day, this is the high and this is the low, right? So this is what we have. Let's check. What is that? As you see, date is a string. Okay, I just wanted to show that again. I know that we did this before, but let's quickly be done with this example. So what I'm going to do is next is I'm going to drop this very first row because we see that there is something wrong in here. I'm just going to drop it. So there are again very different ways of doing this, but what I'm going to do is I'm going to use the index number. Okay, this index 0 means the first row. I will simply going to drop it. Okay, I dropped it. Let's see how it looks like now. Yeah, it's gone. Okay, next thing is I'm going to take this data set, this corrected data set. Now, I just want to show you that now let us save this data set. Okay, let us save this data set as a CSV file. Okay, let's call this Apple 2. Right. Okay, here is Apple 2. Perfect. Now let's take this data set one more time. All right, if you like, we can what is it? We are going to use this data set later. That's why I said it. So I'm going to come back to this data set again. But before doing that, what I want to do is I want to change the format of this date column as it is now a string. I want to change it into date time. That's what I want to do. Okay, so date. Now we can do the reason why I'm going through this exercise is the following. Earlier I showed you that you can read a CSV file here. You can, where is it? You can read you can read a CSV file using pandas, and as you read, you can assign the date as the index column, and you can even change the date columns format, okay, from, in this case, string to date time, okay? You can do this as you read the data. I want to show you here that we can do this explicitly ourselves after we read the data, but as we were reading the data, we didn't do that, okay? The reason is we couldn't do that is because, as you see, there was one value here which was not making any sense. So first of all, I need to get rid of this. After I got rid of it, I saved it as a CSV file. Next, I'm gonna use this file to load it on the platform, okay? But for now, let's do this manually. So I'm going to change this column from string into date time, okay? I selected that column. Whatever will happen, I'm gonna assign it to this column, okay? So what I'm gonna do is I'm going to use to date time method of pandas, okay? To date time. So what am I changing to date time? DFA's date column, right? So I'm changing this column into date time, all right? But when I'm doing this, I need to define the current format, how this guy looks like. How does it look like? So the format of this column is, okay, first I have the year, like 2018, okay, slash, and then the month, okay, this indicates the month, slash, and then the date, okay, this is the current format, okay, take this string which is in this format and turn it into a date format and assign it back to date column. So let's do this. Now let's check our data set one more time. Okay. As you see, the only difference we see is instead of these guys, I have the, what is that? Like hyphen, right? So, but I need to see more than this. Let's check the info for me. Okay, now date is date time. Okay, it is not a string anymore. It is a date time object, right? Okay, good, very good. So we did this manually, and then we have, oh, by the way, let's also check the columns of this data set. Date, close, blah, blah, blah. So what I want to do next is I want to assign date, this column, as the index. Okay, that's what I want to do. So what I'm gonna do is DFA, I'm gonna set index. Okay, I'm gonna set date as the index, and I want this happen on this data set instantly. Now let's see how DFA looks like. Okay, as you see now, index is changed into the date column. So date column itself is becoming the index. That's 0, 1, 2, 3. This column, actually 0 was gone earlier, right? We removed it. So this index is disappearing, and then instead I have this index here. So, okay, so this was just an exercise for how we can deal with parsing date columns format, right, from string to date. Now, next, I want to show you a different way of doing this. Okay, a different way of doing this. I hope this is going to be helpful to you guys when you are. This is the very first step, but again, I guarantee things we do wrong in this first step is going to cost a lot later on when we develop models. So we have to be comfortable here. Again, from date time, I'm going to import date time. Okay, not date time. Okay, so this time what I'm going to do is I'm going to read my data set directly. Now, what is my data set? Apple 2. Remember, I removed the first row, right? So this is the nice data set, Apple 2. Okay, I'm going to take this. When I'm doing this, I'm going to say that, you know what? Explicitly, I'm telling parse this column into date format. Which column? Date column. Okay. Comma. And also, I'm assigning a date, the same column, as an index column. So I'm doing this part here. Okay. And on top of that, I'm doing one more thing. I'm going to tell how to parse date into date format. So I'm going to define a custom-made date function. Okay. So let's call this date. This is date parser is. I mean, it's part of read CSV. Okay. So I'm going to assign the argument custom date parser. Okay, so this is the function that we are going to create, this date parser is part of read CSV as parse dates index column date parser. You can check pandas read CSV. You can check what kind of methods and attributes pandas read CSV has. So this date parser is we are going to assign a value. Our value is custom date parser. Now let's define what custom date parser does. Custom. This is a function defined by us. So let's define it. Okay, custom date parser. Okay, it's a lambda function. Okay, again, if you don't know what lambda is, it's very simple. That basically this function is going to work on each row one by one. Okay, what it's gonna do is it's going to take this x value. So in this case, it's gonna work on each date value. Actually, it's gonna take this x value. Okay, and then it's going to use date times string parsed into time. So this what this method does is it's coming with date time. What is date time? It's a date time library. Okay, so we are using date times strpt time method, and then what we are doing is whatever x is, take x in this format and change it into date format. Okay, what is the format of x? We already learned about that. It's year, then month, and then day. So where is this coming from? This coming from the original data set. We checked the original data set. This is the format for this date column. So I take this, I'm exactly expecting in this format, the first couple of strings, okay, or characters before this backslash is actually indicating year. Okay, that's what it says, year. And then the next between two backslashes, whatever the characters are, they are for month. And the last part after the last backslash is indicating days. Okay, so let's run this. So let's call this DFA2. Okay, so that's, we can see the difference, if there is any difference. Okay, so there is one difference, right? There is one difference. So let me run this one more time. Because I'm sorry, I already changed DFA, so that's why it's giving me this error. It's okay. Yeah. Okay, so this is the DFA that we did earlier, and this is DFA, the new the same data set that we did using this custom defined parser function. So the difference is now we have this unnamed column. What is this unnamed column? This unnamed column was the index column from the original data set. So when we did this manually, the index was dropped, original index was dropped, and then it was replaced with date as the index column. In this case, the original index column is not dropped. Sometimes this may be very helpful. You don't want to lose an index. Let's say this is an index column. This is our index column. I don't want to lose it. I want to take this back into my data frame as one of the columns. I don't want to lose it, right? So sometimes it's going to be very useful not losing index column. Again, the other way, you can also not lose it. I just wanted to show these minor differences, okay? Anyways, and now you can, if you like, let's do it. You can lose this column. Okay, I think I spent too much time on this. Let me finalize this. EFA2 dot drop. Unnamed. That's the name of the column. Okay. X is 1 and then in place 2. Okay, perfect. All right. I'm done with this. What is that? With loading this data set. Next. Oh, there is a question here.
Dr. Jeran, are you going to give any break?
Yeah, let me give a break. Sorry, so I just lost myself. Okay, I'm going to give a short break, and then Dr. Badai is going to talk with us during the break time. So don't go anywhere. Okay, I'll be here. Okay. So sorry. So
no problem. Yeah, my talk is not as challenging, so I won't make jokes too, but it's still break.
Okay, let me stop sharing. Yeah.
Okay.
Then
so it's good that I've been keeping eye on the participants and with the same participants and here for all that time. That means it's very good engaging. So hello everyone. I just give a brief introduction. Myself, I'm Murat Badai, Stanford scientist and serial entrepreneur and co-founder of Magnimind Academy. And I've been doing AI work for last 20 years, started with particle physics, biophysics, now a lot of AI in medicine. And part of our specialty in Magnimind Academy is also, we have a very strong AI in medicine, AI in finance, AI in marketing specialty. And I wanna if you're not part of our meetup groups, our friends share the meetup groups and please welcome to join any of those meetup groups. We've been organizing these events for I think it's close to 4 years now. We organize around 300 events. And we hosted more than 50,000 people. There are a lot of free workshops, lectures. And then our events are also in YouTube. So our YouTube channel is very rich content. But we don't post such workshop and such series of workshops or mini boot camps in YouTube. That's special for the registered people. And we have all the other our YouTube channels. One thing I like to request, if you don't mind, to give us reviews, so that will help us to continue our events, free workshops, lectures, series. If you give us a feedback in our review page, we appreciate it. I know so many people want to do it, but sometimes they just procrastinate, don't get the chance to do it. And we've done a lot of those free programs for a couple of reasons. We have our investor that have been helping us, and we have our volunteer crew that have been helping us to keep going those events. Please don't hesitate to put a review. I'm just gonna repost the review page myself, so that's really important. If you appreciate it, if you think you're benefiting from it, please just write a review. And I'd like to also introduce a special program. Mentorship program is way different than many other similar bootcamps doing it. It's very unique itself. We have a mentorship plus internship program. I will share my screen if I can. Okay. So mentorship, we used to have this as just mentorship alone. We have mentors from top companies and we have mentors from Magnimind to help the people to get ready for the job market in industry. And now we combine this with the internship program. We've been doing this one for a while. And let me see if you, okay, now you should be able to see the screen. So in this program, you work on several projects with our mentors. You get to know 3-4 mentors from Magnimind and Magnimind affiliated mentors from top companies. And we help with the interview prep, and we help with interview or career coaching. And we do interview Q&A sessions and resume support. And more importantly, you will have a chance to work with different projects with different companies. And some of these projects are with companies that are also involving Stanford University or similar universities, some academic aspects, some industrial aspect. So very intense, very rich content program. It's 15 weeks. You see, first 6 weeks, we have 3 modules. And so first 6 weeks, you'll do 5 to 6 projects to get you ramp up to your skill set in doing projects. But the rest of the 9 weeks, you'll do actual project in real time with the companies. They're trying to build new modules, new AI, new data science products. So the goal with this one, if you finish 15 weeks, you should be able to do the job in any company. But the one thing that we prerequisite is you've been working on data science for a while. That's how we select students. And if you've studied a lot, but you don't have a chance to flourish your skill set, and you don't have a chance to do internship, because that program is good for you. So this is for some people that have been studying it, but don't have the follow-up guidance and chances to do what we provide. We have a limited spot, and that positions open time to time, but we take the students in certain periods. And annually, we don't have that much positions. We have like 25, 30 positions. So if you're interested, you can send us email. We can schedule a meeting and understand your background to see if you're fit for it. And you may think that you're really fit for it, perfect for it. That's fine. So a lot of our also students come with master's degrees, some other boot camps they finish. So we have a lot of those, and so many of them also self-study people. So yeah, if you have interest, and please just send us email. I will share my email as well, as long as Magnimind general email. So if you send an email to me, you should also include Magnimind, so they will follow up with your inquiry. So I will give you a few more minute breaks so that Dr. Jiran can come in a few minutes later.
Thank you, Dr. Baday. I'm here, so let's wait for 3 more minutes. Past 13, we are going to start. All right. Hello again. So let's continue from where we left. I mean, we are going a little bit slower than, I think it's my fault. Maybe I should go a little bit faster, but let's see. So there is one question on capitalized Y when we were using dates here. So if you just search for date time, so I just did a search just to answer this question. So small y is only going to show you the year part of without century, like instead of 2018, you're just going to see 18 with small y. With capital Y, you're gonna see the full version of the year. Again, small m is for month as a number, but capital M is for minute. So you need to just check what each letter corresponds to when you define the date format, okay? So custom date time and parse date is doing it, automatically. So custom date time, you can create your own function. If you want to do some additional things on the date, okay, you can create your own function without relying to pandas or Krishna. So that would be my answer. So I already shared today's resources with you. So let's continue. Yeah, let's continue. Oh, I didn't to copy paste for the chat conversation is not available. So another person is saying so. Sorry. So I thought it was available. If we can make it available, let's see if our friends can make it available. Otherwise, if you need anything, I mean, from the chat, so I can try to share it with you. But let's continue with the class now. Okay. Before I go to the next topic, I want to give you one more example on rolling windows. Okay. At this time, the example is going to highlight one minor thing. All right. So remember, let me first write the line for what I'm talking about. So here is my what is it? DFA data. So this one here, this one. Okay, so I'm going to take DFA, but this time I'm going to focus on the column called close. Okay, so I'm going to take the close column. Again, that is the name of this column. So I'm going to create a rolling window for this column. Remember, we did this before, right? A rolling window for this column. And the width of the window is going to be 3. Okay, so that means for any close value, let's say for this third, I'm sorry, the third one, 20447, I am considering the data points 2 before this 204.47. All these 3 data points. That is what it means. So I have a window of size 3, but this time I'm going to in the earlier examples, when I consider the window, I give equal weight to each data point in that window. So when I was finding the summation or finding the average of the data points within that window, I was treating each data point as equal in terms of their weights. So what if you want to treat them differently? What if you want to assign them different ways? For example, and then we do this very frequently. So actually, that is one of my plans. I want to work with you guys on a project which we are going to predict requests for taxi in a certain location. But when we are developing our models, we are going to put more weight on data from recent dates. For example, I'm going to put more weight on the data from yesterday than the day before yesterday, because yesterday is more relevant to today than maybe more relevant to today than the day before yesterday. So yesterday may be more relevant to today than the day before yesterday. So I'm going to assign more weight to yesterday, less weight to the day before yesterday, less weight to the day before yesterday. Okay, so we can do this manually, which I did this in general. I do this whole manually, but here I just want to show you an example where you can define different window types. By the way, you can check what types of windows are available. I'm not really into this too much, but I just wanted to emphasize that there are different ways, and I do this manually, but there are different ways of assigning weights to data points within a window. So in this case, I'm going to use triangular window. And then I'm going to show you what triangular means. So when you do this, and then search for rolling windows, wing type triangular, and then try to see what is the weight for this triangular, you may not find too much of an information, but I'm going to show you what those weights are in a minute. Okay. So, and then after, let's say, when I type this code, I already created a rolling window on the closed column of my data set, a window width of 3, and this time window type is triangular. So this whole thing is just a window. Now I want to do an operation within each window, right? So the operation can be sum. So the moment I do this, here I am making a sum within that window for the data points within that window. As you see, the first 2 data points are not a number. Again, my window width is 3. So the first 2 data points do not have any data points before them. So that's why the first data point, there are 2 data points missing. The second one, there are 2 data points are missing. The 1 data point is missing. Now the third one, I have 1 full window with data points. That's why I have a summation here. The question is, if I go to the next one, and then let's do this here without defining the window type, and then just use the default. Okay. All right. So what is the difference here? What happens? Why it is 392.52 here, but it is 590 here? Okay. The difference is I am giving different weights to 3 data points within each window. That's the difference. Okay. And then if you wonder what are those weights, again, I did some search on it, and then what I found is I can import triangular from SciPy's signal Windows library. Okay, here it is. And then you will see what it means, triangular, in a minute. Okay, and I am creating a triangular with the size of 3, which is going to give me the, you see, so I have, within each window, I have 3 data points. The first and the third data points have 0.5 weight. The one in the middle has full weight. Okay, so this is triangular window. Imagine that your data is passing through a triangle. As you see, the first and the last one are actually reduced, and the one in the middle keeps its amplitude as, weight as 1. Okay, all right. So we understood actually what it means. Let's continue with our example. Actually, I can even give you, that's another thing. And then after this, I'm just going to get to the next topic, okay? I did some search on how you can create your own triangular sum. So that's another thing I want to share with you. Maybe you can use it. I never used this before, but you can create your own function. And then here you can, what is that? Yeah, you can create your own function. Let me show you how to do that. And then I'm just going to move forward. Okay, so weight. Now, this triangle, sorry, this one is the same thing that we imported from SciPy. Okay, here we said the size is 3. Here I am making window as an argument, right? So it can be 3, 4, whatever. And then this returns weights times the window and then summation. So I'm doing the same thing I did in here. Okay, I'm doing the same thing I did earlier, but here I am defining a function for that. Now let's do the same thing with this. Again, DFA. Okay, this is my data frame. This is the closed column. Now I have the rolling window. Okay, I have the rolling window, and then I'm going to apply triangle sum. Hopefully this works. Was rolling. Oh, window is 3. Okay, 3. Yeah, it worked, right? So it hopefully it gave the same. Yeah, it gave the same result. Okay, so if you like, you can define your own function here. It doesn't have to be this triangle, so you can create your own function. You can give different weights, actually. So these weights, make this 3.5. Hopefully this works. I'm not sure. As you see, I changed the weights. If you like, you can give your own weights, depending on what you, so here the results are totally different. All right, any questions? Thank you. To evaluate a model, we need to select a metric and compare to a baseline, like a naive forecast. Yes, I'm going to talk about naive forecast, hopefully at the end of autocorrelation. So there are different ways of doing naive forecast, but naive forecast, we can call it using today's value as the prediction for tomorrow. This is going to be a naive forecast, or taking the average and use it as a naive forecast. So you need to come up with a baseline model, which is very simple, intuitive, and then you can compare it, whatever model, sophisticated model you have, compare it with this baseline model. If your sophisticated model is not doing as good as the baseline model, there is something significantly wrong. Okay. All right, now let's talk about the next topic, resampling and interpolation, which is, again, very important when you are dealing with time series data sets. Again, you might use this in many different contexts. For example, you receive a data set, which I'm giving an example from what, I mean, a lot of things that I use this for, but one example. You receive a data set which is giving you daily sales of products, all right? So, when the data was recorded, some of the days are skipped. Okay, so this may be due to some error, right, in the system, where some days the computer did not work, or you didn't record the data, or you may not have data on that day. Something happened, right? So you don't know, but that day is missing, or sometimes days are missing. Some maybe 2 weeks missing. Okay, imagine that you have data set, a time series data set. In between, there are some gaps. Okay, but when I say gaps, you don't see them as data points. So there is data for January 1st, and the next data point is for January 10th. So there is this 9 days of gap in between January 1st and January 10th, right? So how are you going to treat these kind of data sets? So there are different ways you can do, but if you want to work on daily basis, let's say there is another data set which is giving you data for each day. For example, here you are missing the sales data between January 1st and January 10th. But in the other data set, you have customer review data for all the dates between January 1st and January. So you have review data for January 1st, January 2nd, January 3rd, and you want to combine these two data sets. Okay, you want to combine or do something, okay, in these two data sets. So one thing you can do is between January 1 and January 10th. So you want to open that gap and then make it January 1, January 2, January 3, January 4, and then January 10th. And then you want to give some value to January 2nd, January 3rd. It's going to be 0. So when you write 0, you might be a little bit uncomfortable, knowing that on those days, most likely there were some sales, but the data was not recorded. Okay? Then how are you going to fill? This is a missing value, right? How are you going to fill in those missing dates, the sale numbers for those missing dates? So again, there are different ways of dealing with this type of a problem, okay? But here is an introduction to that. So what we can do is, first of all, we can expand between January 1st and January 10th by day. It means I'm going to create days for the gaps. And then let's say I can use the last sales data to fill in any missing value between now and the next sales data. For example, I'm on January 1st, but January 2nd, there is no data, right? So I'm gonna copy January 1st sales number to January 2nd, January 1st sales number to January 3rd, until I get January 10th, where I have real sales data. So I can fill, this is forward filling, or you can use back filling. I'm gonna give you an example in a minute. So, or I can take the average of January 1 and January 10, and then fill in all the missing values with the average between these 2 dates. So there are different ways you can do it. That's what this topic is about. Again, it's very important to actually prepare your data set for any kind of model. Okay. So for that, we are going to use resampling and interpolation, right? And I'm going to import shampoo sales data set, which I shared with you already. Sure. So the recording of this will be available at YouTube channel. Okay, Magnimind's YouTube channel. All right. So let's import again pandas, and then I'm going to import datetime. From datetime imports. Now you know what I'm trying to do, right? So let me first import the data set and then show you how it looks like. Okay, let's call this shampoo data. Okay, shampoo. So this is gonna be PD read CSV, and my data set is, where is it? Shampoo sales. Shampoo is that CSV. Okay. Let's check our data. Okay, first of all, let's import the data, and it gave an error because it's not shampoo, right? Yeah. Okay. Okay, so here is my data. This is the index. My data has 2 columns. The first column has the month. Probably the first one is the year. The second one is the month. Or maybe this is the first month, and this is let's look at the entire data set. Okay, so yeah, the first one is the year, the second one is the month, right? So there are 12 months. This is the 3 years of data set, and the second column is the sales. Let's check. So again, sales is a floating type of data, and then month is coming as text. So we need to parse this text and then change it into time format. Okay, so we know now how to do that, right? So let's use what we learned earlier. So what I'm gonna do is I'm going to go all the way up and then see what we did earlier. When here, right? So I'm gonna do the same thing. Let's see if this is gonna work. Okay. You see, each time you might face with a different problem. So you need to do a search, but carefully. Okay. So okay, let's see. The index column is this time there is no date, but it is month. And then I'm gonna parse dates. Let's see how this looks like now. So it looks like it works. Okay, it worked. So now this is a date time format, but again, this is just a year. I understand it is year, and this is, I understand it is the month, and this is the sales. I want to do more than this. What I want to do is, as you see, between this, the first and the second month, is there any way I can create a data set where I'm gonna have all days in a month, like first day of the first month, second day of the first month, third day of the first month. In other words, instead of having, what is the size of this data set? I have 36 data points, 3 years of data. Each data point corresponds to sales within 1 month. Can I make this data set 365 times 36? Okay, 365 times 30, I'm sorry, 365 times 3, right? So can I create a data set of 365 by 3? So each year, 365 days. So I want to expand my data set for each month. That's what I want to do. Okay, can I do that? Well, the answer is we should be able to do that, right? We should be able to do that. But before getting into that, I like the way this date looks like. So I want to make it more traditional looking year, like 1981, 1991, but I don't have any idea what is whether this is 1981, 1991, 2000. I don't have any idea, right? So I'm just going to make this like 1901, okay? And then 1902 and 1903. Again, because I don't have any idea about what is the century, right? It is 19th century or 20th century. I don't have any idea about that. Okay, so how can I do that? So one way is, let's go back to what we did for creating our own function, parser function, and then use that function. So let's create our own function. Let's call this parser x. Again, here you can, if you like, as we did earlier, you can use a lambda function, or if you like, you can create a traditional function like this. Okay, both will work. Both will work. What I want to do is, from, again, as we did earlier, from date time, I want to change each date. Here, X is each date. I want to take the text, okay, the string, and then that string is going to be in this format. Okay, it's going to be in this format. As of now, it is in this format, year, and then month, right? That is the format. This is the format of my month in my current data set. What I want to do is take this guy in this format, okay, and then add this 19, okay, plus X, okay. So this X is coming in this format. All I want to do is add 190 before the first character, and then turn it into a date format. That's what I want to do. Okay, this is my function. Now let me read my data one more time. I'm just going to copy this here. Let's call this 2. Okay, let's call this 2. This time, what I'm going to do is index column, index column month, okay, parse dates. I'm going to parse the dates, but I'm going to use a specific function for that. The parser is my function, which is parser. Let's see if this is going to work. Forget a comma. Yes, because I need to put a comma after this one. Okay, now let's see how my data is going to look like. And it gave me this. So why do you think this is happening? Gave me this. Let's see, parser. I'm just seeing if I did anything wrong. 190 plus X, and this is minus M. Everything looks correct. And this is index. Let's remove this and then see if it's going to work. I don't think it's going to make any difference. I mean, it didn't work. Anything wrong as you see here? Yeah. Slash. Let me see. Our date parser is this. I don't see anything. You mean this one, right? So I don't think it's going to make any effect. So let me say index column is 0 for now. See if this is going to work. No. So there is something that I did wrong. I'm trying to figure that out. Just 1 second. Shampoo sales. I'm reading my data, and then my index column is this. And then I say parse dates should be here, and date parser is parser. And then this is my parser, and then I am calling, of course, I need to return, right? Return this. I forgot to return it. Yeah. Sorry about that. Yeah, it worked now. Yeah, small mistakes. It takes time to figure that out. Sorry about that. So yeah, now we have the date format changed into 1901. So you can add whatever you like before X. Here I just added 190. Okay, so this is my data set. Hold on, let me see if there a return. Yes, Raz, thank you. Thank you for reminding me that. Fixed, yes, thank you. All right, so let's continue. This is the data set. Next, what I want to do is, as I said, I'm going to sample my data set. This time I'm going to upsample my data set. In other words, for the month of January, I'm going to create the dates for January. So let's do that. For that, I'm going to take my data, which is data SH2, and then I'm going to resample it. And then I'm going to do this at day level, okay? So let's see how it's going to work. When I run this, it is only returning me some object, which is stored at some address, similar to the window function or expanding or rolling functions we used earlier. So I need to do some operation on this. So what I'm going to do is, I'm going to assume that I'm taking the mean of each day, okay? So let's see how it's gonna work now. Okay, I think it worked now, right? So here is my, let's do this. Let's assign this to a new name, upsampled. And then let's print the first 32, add 32 data points. Okay, so as you see, I have between January and February, I have all the dates now. The thing is, originally I had the data for the first, this is the whole month, and I have this for the second month, and in between I don't have any data set. I don't have any sales data. So what am I gonna do with this? Am I going to just assign a 0 value, or am I going to divide this by 31 and then assign it to each day? So it depends how I'm going to approach this problem, okay? It depends. I need to have some more information about how this data set was collected. But we're gonna make some assumptions and then try our best to fill it, okay? All right. What should we do now, next? So what we are going to do is, I'm going to, instead of having these not a number values here, I'm going to add some value here that I'm going to call it interpolation. What interpolation means is from 266 to 145, I want, let's say these are 2 points in the coordinate system. In between these 2 points, I'm going to draw a line, right? And then for each day, I'm going to pick the value from that line. That is what linear interpolation means. Let's see how it looks like. Okay, let's see how it looks like. So what I'm going to do next is, I'm going to say upsampled, which we just created. Okay, I'm going to interpolate this linearly. Let's see what this looks like. So as you see, from the January to February, there were only two data points. In between these 2 data points, imagine this is on a coordinate system. We draw a linear line, and then on that linear line, slowly, as you see, there is a slope, right? There is a slope of that line. So slowly, from this data point to the next data point, we are reducing the value. That's what's happening. Again, if assumption is that 266 is not the monthly sales, but it is the sale specifically on this day, then of course the best thing we can do is from one observation to another linearly, we can either reduce or increase the number of sales linearly. Okay, that's what's gonna happen when you do interpolation. What I'm going to do is, I'm going to just plot this and then see how it looks like. Let me make this equal to interpolated. Okay, and then I'm just going to, by the way, if you have any questions. Yeah, please let me know if you have any questions. So from matplotlib, PLT. Okay, and then I'm just going to interpolate it. Let me just plot this, of course, interpolate it. So what we see here is, right, between January and February, this is February of 1901, there is a linear line. Because we only had 2 data points, in between 2 data points, we draw a line. Again, from February to March, another linear line. So as you see, between the months for the missing values, we just filled in the missing values, assuming that the sales are linearly increasing or decreasing. Okay, you can make different assumptions, but this is what the assumption we made for now. So okay, here is another way we can fill in the missing values. Okay, so what I'm gonna do now is, again, remember this is upsampled. Remember this is upsampled. Upsampled has missing values in between 2 data points. I'm gonna take upsampled, and then this is something that I frequently do when I have missing values. You can either fill that using backfill or forward fill. So let's see backfill first. Let's see what backfill means. Okay, and then I'm just going to backfill the first 32 data points. Okay, so what happens is, remember, this was the first data point, and this was the second data point. This is the 1st of February. So what we do is, in between, there were all missing values here, right? There were all missing values. What we did is we took the February's data and then filled in all the missing values before this date. So depending on the context, you may prefer backfilling or forward filling, depending on the context. Okay, here I did backfilling. You can do the same thing. By the way, let's also plot this and then see how it looks like. You're gonna see that there are some straight lines. So backfilled plots. So again, like sorry, step function, right? So between, say, January and February, so from January to February, I'm using February sale to fill in the missing values. From January to March, I'm using March value to fill in the missing values. I can do the same thing using forward filling. This time, upsampled. Instead of backfilled, I'm going to use forward filled. Just fill. Okay. Let me first. Now, as you see, the first value was 266, and the next value is 145. Between first and the second value, all the missing values are assigned to 266. Basically, I take the first value and then forward fill for the missing values. Okay, and these two are not going to look so different. Okay, forward filled F. Let's call this. They're not going to look so different. The difference is the first, as you see, the first between January and February, I'm using January's data. Okay, but they look alike. They look alike. Okay, now let's make this a little bit slowly, make it a little bit more and more sophisticated. Okay. This time, I'm going to what is it? Instead of upsampling, I'm gonna do it downsample. Okay, let's call it resample. I'm gonna downsample means here I filled in between months. It's like this is between January 1st and February 1st. I created days. What if I want to collapse my data into quarterly levels? Okay, can I take 3 months and then collapse it to take the mean of the sales within 3 months and then assign it to a quarterly value? So I can do that too. So let's do it that way. So what I'm gonna do is, again, what was my data? Was not upsampled. Data SH2, right? This is my data set. Okay. I'm gonna take my data and then I'm going to sample my data at quarterly level. Okay, let's see what this is going to look like. Again, as you see, this is just an object. I need to do something on this. So I am sampling my data quarterly, but in between quarters. In other words, think of quarter as a window. In that window, there are 3 months. What are you going to do? So for 3 months of data, I'm going to take the mean of that. Okay. The moment I do this, as you see, I'm sampling quarterly. So the 3rd month, which is March, and then the 6th month, and then the 9th month. But March data is the mean of the data from March, February, and January. Okay. So let's assign this to quarterly mean series. Okay, and then let's plot this. It's going to look smoother. As you aggregate data, the data will look smoother, right? Nice. Okay, it looks more smoother now. So these are quarters, right? Instead of looking at month level, now we are looking at 3 months level. Okay, all right. So what else can we do? Well, we can do this annually, if you like. So let's do it very quickly, annually. This time, instead of quarterly, I'm going to say annually, and then let's this is yearly. Okay, so as you aggregate the data, it becomes smoother, but you are losing a lot of information, right? Now it is 1901, 2, and 3. Of course, you need to change this month into year. You have to work a little bit more about the X label, but I'm sorry, X axis. But you can aggregate your data, collapse your data, or if you like, you can sample your data, upsample your data, and then fill in missing values. All right. Okay. I hope this part is clear, because I want to now move into moving averages and then stuff for today. Yeah. So, I mean, if you, Hania, we can send the module links to modules in the emails too. No problem. Sure. Any questions? Anything you want to? Is interpolation done based on a certain defined problem? When is the best case to use it? So, Krishna, most of the time, we do interpolation when there are gaps in the data set. Okay, when there are gaps in the data set, as I gave you the example of sales data set, there might be the cases that for certain couple of days or weeks, we may maybe be missing data, right? So in that case, we interpolate, or let's say you have data for taxi requests for Uber drivers or taxi, but normally your unit of time is 30 minutes, but in some cases the data comes in hours. So 1st hour, 2nd hour, 3rd hour. So then again, you need to interpolate and then upsample your data into 30 minutes and maybe fill in the missing values. So this is if your entire data set is on daily basis or on monthly basis, you may not even need to interpolate or upsample your data. The problem arises when a significant part of your data comes in, let's say, 30 minutes of time intervals. And then for some cases, for example, for some of the neighborhoods or some of the drivers, data was collected on hourly basis, right? So in that case, in order to accommodate data coming from all the drivers, if majority is coming in 30 minutes intervals, so for some drivers coming in hourly intervals, you may need to upsample those data and then merge them, right? So again, depending on the problem, there might be many cases where you need to upsample and interpolate your data set. Okay, next. So this is one of the simplest ways where you can create some, predictive, very simple predictive models in time series using moving average. We are using moving average to smooth on the data set. Also, you can use it to make predictions, all right? Again, we already learned about how to create rolling windows. So we're gonna use that, but this time we are going to use that for the moving average purposes, okay? So again, let's use which data set? Daily total female births data set, okay? That's what I'm gonna be using. So again, for the sake of completeness, let's import pandas. Okay, and also let's import from matplotlib. Okay. All right. Now I'm going to get my data, births data. Let's call this B data. Okay, PV, read, CSV. We know the drill now, right? So daily. What is it? Total. Yeah. Female. .csv. Okay. All right. So this is my data set, and then I'm just going to say index column is 0, and then parse the dates. True. Let's see how my data looks like. This is the date, this is the number of births, and then as you see, my data is on daily basis. And what is the size of my data? So I have data for 1 year, right? 365. Okay. Now, what I'm gonna do is, again, we did this before. I'm going to create a rolling window of width 3. Okay. So let's call this rolling. So I'm going to take my data. My data has only 1 column. And then I'm going to create a rolling window of size. You don't have to say window equals 3, but to make sure that what you mentioned when you say 3, let's put add window. So window. So when you run this, and then again, just let's make sure we understand. Rolling is just a rolling object. Okay. So now we need to do an operation on rolling. Let's take the mean of that. So when we do this, as you see, we are taking the mean of 3 data points falling into the window of width 3. Okay, so that is, let's call this rolling mean. Okay, so we have the data set. So what we want to do is now let us plot this. Okay, let us plot this. So plt.plot. First of all, let's plot our data. Okay, so this is our data. So on top of that, let's also plot our rolling mean. Okay, let's make this red. Color is okay. So again, we didn't do much, right? So this is our original. The blue one is our original data set. The red one is a slightly smoothed version of my original data set. I say smooth because I am taking the average of 3 data points. Okay, I'm taking the average of 3 data points. As you see, I keep the trend. I keep the way my data looks like, but I almost like trim these spikes here, right? So let's get a little bit focus on that and then see how it looks like. So let's look at the first 100 data points. Okay, this is the first 100 data points. Yeah. Instead of V data, this is rolling. And then the color is red. And this is rolling mean. Okay, so this is just showing a little bit of, what is it? Zoomed in version of what we just saw. Something you notice is the rolling mean is is following our data a little bit with a delay, right? A little bit of a delay. You see here, data starts from here, but our rolling mean is because we are taking the average of 3 data points. In other words, the first 2 data points have to be considered with the third data point, and that is going to give us the first data point in our red line. So that's why it looks like a little bit shifted, right? The mean is a little bit shifted version of our original data set. Okay. Now, oh, by the way, if you, yeah, that is something I did here. Let me see. If you want to make this look a little bit nicer, yeah, let me just give that too, so that you can work on it later on yourself. If you want to make these dates look better, so as you see, the dates are very confusing here. X takes, let's rotate it by 45 degrees. Okay, this will work. Yeah, as you see now, the dates are much more meaningful. Okay, almost done, guys. I know that some of you guys are already very tired. Almost done. So what I want to do next is, let me check my time. Actually, I have another meeting. Oh. So where there may be a day of week effects as in reported COVID ER and hospital, it makes sense to use a 7-day moving average as many media outlets. Yes, yes. So we might have a 7-day. So again, depending on how the data is used, it can be 7-day, it can be monthly. So depending on the context, Andre, thank you. And Zuhair, for the mentorship program, the coupon does not work. Zuhair, please send an email to Magnimind, or they are going to get back to you immediately. Okay, please let them know that the coupon is not working. They're going to take care of it immediately. How does this moving average session relate to the MA model? Yeah, so we are going to actually, we slowly started talking about ARIMA model. So we are going to use this MA there, okay? And then I was planning to finish today autocorrelation too, that will relate to AR. So slowly we're going to put things together. That's why I'm spending going a little bit slow, so we understand the basics really well, so that later on we are going to have these aha moments. Oh, okay, that's why we are using ARIMA model. Oh, that's what MA is referring to, AR is referring to, why it works. So that's going to, right now, what we learn in this slow pace will give us insights later on when we learn about the models. Okay, so again, I'm sorry, guys. I need to stop here because I have another meeting. Actually, I'm late for 1 minute. So let me stop here, and promise next time I'm going to be a little bit faster, because I already, I couldn't finish the second module yet, although I have the third module. So let's meet next time, next Thursday. We're going to finish this and what is remained from today and the third module. And then hopefully we're going to slowly get into time series models. Hopefully it's going to be useful for you. So thank you very much for listening. I'm going to place the updated file on the drive right now. Otherwise, I'm going to forget. Okay, so I have to go. I'm going to place the updated file, and then I'll see you guys next Thursday. Okay, thank you.